Number 5, the space shot is a ride at an amusement park that propels passengers straight into the air. A spectator is standing 20 meters away from the ride. Let h be the height of the passengers on the ride from their original starting position, and theta be the angle of elevation to the passengers from the spectator. So we've got a little drawing here. We've got this ride here. These are where all the passengers are. You got this guy standing 20 meters away from the ride. He's looking up, watching as these passengers on this ride get shot up in the air. And what we're asked to do is find a formula for the height of this ride as this angle increases. So let's start by looking at this triangle here. This is a right triangle. And we know from back when we were talking about right triangle trig that to find this height, that's the opposite side from this angle, and we know the adjacent side. So we're going to use tangent to find this. We know that the tangent of theta is going to be equal to the height over 20. Opposite over adjacent. And now we just need to solve for h. Let's multiply both sides by 20. And we get that 20 tangent of theta is equal to h. These will cancel out. And let me write that the other way, just so h equals 20 tangent of theta. So there's our equation, and that's the answer for part A. Part B then asks us to graph this. And so, first of all, if we plugged in 0 for theta, the tangent of 0 is 0. So this whole thing is going to be 0. The height is going to be 0. So we can mark that point. And that should make sense, since if this guy is looking straight across at an angle of 0, angle of elevation of 0, meaning he's looking parallel to the ground, the height is going to be 0. They haven't gone up at all. And then at 90 degrees, let's think about where it would be at 90 degrees. The tangent of 90 degrees is undefined, which means that this whole thing is undefined. So we're going to have an asymptote at 90 degrees. And that should make sense also because as this guy is watching this go up in the air, there's no way that this ride that's 20 meters away from him is ever going to be directly above his head. That would be impossible. It can get really high and it can really make him crane his neck at a difficult angle, but it's never going to be 90 degrees because that would be directly above his head. So we're going to have an asymptote there at 90 degrees. At 45 degrees, the tangent of 45 degrees is 1. Remember, 45 degrees, or pi over 4 radians, that's right where both the sine and the cosine are the same. And so the tangent is going to be 1, which means that the height here at 45 degrees is going to be 20. And then remember that the tangent makes this kind of this curve that goes like that. And so from here up, it's just going to curve, and then it's going to get closer and closer to that asymptote. As it gets closer and closer to that asymptote, it's going to go up to infinity, theoretically. All right, so that's the graph of this equation. Now, the last part says approximately how high are the passengers when the angle of elevation is 55 degrees. So at 55 degrees, about how high are they? And to find that out, we're just going to plug in 55 for theta. So the height is going to be equal to 20 tangent of 55 degrees. And we can plug that into a calculator we're going to get, that's approximately equal to 28.6. This is in meters. So it's going to be about 28.6 meters off the ground when he's looking at a 55-degree angle. And that's it. Those are the answers for number 5.